Okay, 3.4 simple rational functions. To graph any function, you can use the first derivative to find interval of increase, decrease, maximum, minimum. Second derivative to find the interval of concavity and inflection point. For example, let's look at this question. F of x is x plus 2x minus 3. I'm going to share. I'm going to do y is equal to 1x plus 2 x minus 3. Everyone know how to graph this, but let's say if there is any maximum, any minimum point, I need to take a first derivative. The first derivative, this is the quotient rule I'm going to use. Denominator to the power of 2, x plus 2, power of 2, x minus 3, power of 2. Derivative of denominator multiplied by numerator without any change. Denominator is this. Derivative of that, I use the product rule. The derivative of first multiplied by the second without any change. So it's going to be x minus 3 plus now the derivative of second one to the first one without change. It's going to be just derivative of the second one is 1. So it's just x plus 2. So that is the derivative of first is derivative of numerator. Maybe I just erase it and say that one more time. The derivative of numerator is 0, right? Multiplied by denominator without any change. Minus. Now the derivative of denominator multiplied by numerator without any change. Derivative of denominator, I forgot to put power 2 here, guys. The derivative of denominator is product rule I have to do. The first one is 1. The second one without any change. Plus. Now the first one without any change. Multiply the derivative of the second one, which is 1. If I simplify that, it's going to be x plus x is going to be 2x. Negative 3 plus 2 is negative 1. X plus 2 power 2 x minus 3 power 2. Okay. As you see, this is my first derivative. First derivative tells you the increasing and decreasing interval, also give you the maximum minimum point. What I do, I equal it to 0 to find the maximum minimum. Equal to 0 means your numerator equal to 0. 0x equal to numerator. So it's going to be maximum or minimum. How do I know this is maximum? I take a second derivative. If you put plug 1/2 and it's positive, so it's going to be concave up and minimum. If you negative, it's concave down and max. Also, the increasing and decreasing interval, I'm just putting this 0 here, right? Below data line. Above 1/2, I can choose any point, like 1, and below that I put 0 as a test. If I put 1 here, your numerator is positive. Denominator is always positive, so it's going to be positive. If you put 0, the numerator is negative. Denominator is always positive. It's going to be negative. Positive is going to be negative. That means this is decreasing, and then here is increasing. All right, I think I made a mistake. I need to include this negative behind that, guys. Let me just correct myself. If you have negative, this sign will change. Now this become positive. And here you have a negative there. So it's increasing, then decreasing. So you have a maximum here. This is, I know, is max. This is one way to say this is maximum or minimum. So to find, see if we have any inflection point and we find the interval of the concavity, we can do the second derivative. Second derivative is going to be very long. We just do that quickly here. Second derivative. Again, we can use the quotient rules. Denominator to the power of 2. It's going to be x plus 2. It has a power 2. Again, the power 2 becomes power 4. Here is power 2. Another power 2. It make it power 4. Now, to do the derivative, so we have this derivative of this one is a line. So derivative of that is going to be -2. Derivative of numerator is -2. Multiply by denominator without any change is x plus 2 to the power of 2, x minus 3, power of 2 minus. Now I keep the numerator without any change. The numerator is -2x minus 1. So negative and negative turn to positive. And here's 2x minus 1. Now multiply by derivative of denominator. Again, I have to use product rule for that. Let's just quickly do this. I put a bracket, big bracket here. Derivative of the first one is 2 in front, power minus 1, x plus 2. Power is 2 now. 2 minus 1 is 1, so the power of this bracket is 1. And your derivative inside is 1, so you don't need to write it. Multiply by the second term without any change. X minus 3 power 2 plus. Now, first one without any change, the derivative of second one. First one is x plus 2 to the power of 2. Derivative of second one is power in front, so you have a 2 in front. Power in front, power minus 1. Become x minus 3 to the power of 1. Derivative inside is 1, so you don't have to write anything else. Now I can write this numerator in a factor form. As you see, you just do that with different color above. I can factor out 2 and x plus 2. I can factor x plus 3. I do that. So the first term is x minus 3. Back to one of that. Going to be x plus 2 plus x plus 2. I can simplify it further. So this is it. This is 2x minus 1. This is 2x minus 1 also. So it's going to be 2 I have here. X, 2x minus 1 here. Because this multiplied by that. These 2 is here. Now x plus 2. X plus 3. Consider this term and that term to factor out things. See, I can factor out 2. I factor out x plus 2. I can factor out x minus 3, x I believe it should be, this should be x minus 3, guys. I need to allow that, erase that. So I'm factoring out x minus 3 through here. So I don't know why I put x plus 3. So here is x minus 3. I factor out, right? It's there. And here I have x minus 3 again. When you factor out x minus 3 here as well. Bracket. Now from that, I have negative x plus 2 multiplied by x minus 3. This is that. And here is 2 out, so it's going to be 2x plus 2x minus 1. I put this dash, just repeating the denominator from above. I can simplify that one as well. See, this is x multiplied. It's going to be x power 2, negative behind is negative x power 2. Addition of these two 3 plus is negative x, and here is going to be positive because of the negative behind that. 2 multiplied by negative 3 is negative 6, and I have a negative behind, it's become positive 6. I can simplify next step, right? It's 2 again, x plus 2, x minus 3. There you go. Negative x2 x plus 2x is 3x. 6 minus 1 is negative 5, right? Sorry, positive 5. Okay, and I put the dash that is repeating. If I want to do factor analysis, is possible. Okay, I'm going to factor out negative from that. So it's going to be x power 2 minus 3x minus 5. It's not that, okay, so just use a quadratic formula. X1 and x2 is negative b is positive 3 plus minus b power 2. So it's going to be 3 power 2, 9 minus 4ac, 4 multiplied by a, it's going to be 4 multiplied by negative 5. It's going to be positive 20 divided by 2a. As you see, we have 2 roots here. Again, to do the interval of the concavity, guys, we have how many? 1, 2, 3, 4. 4 points that we can discuss the concavity. So one of that is negative 2, negative 2. One of that is positive 3, the zeros here in numerator. And we have 2 zeros here that we have to put there. And again, like this one, find the sign of that, find the interval of the concavity. I'm going to quickly graph this. We have a 2 vertical asymptote at negative 2 and 3. Negative 2 and 2, 3. We have horizontal asymptote at y equals to 0. How? Coefficient of the x power 2 in numerator divided by coefficient of x power 2 in denominator. So this is going to be my horizontal asymptote. I know the the y-intercept here is -1/6. Put x0. So let's say this is this point. I know at x equal to 1/2, I have a maximum. If you put it there and you get that point, let's say approximately here, you just graph it, you go toward the asymptote, never cross it. You go toward the asymptote, never cross it. How do I know I go down, not up? Because there is no zeros. Numerator is always 1. We don't have any zeros, right? I can try one more point. 1. You put it here, 4, and here is -2. Is gonna be okay, 1, 2, 3, 4, right? Boost positive, so let's give you a positive number, this point here. And you go to asymptote, you go toward asymptote, and you put -3 here, get negative, 1/, positive number is positive, so you have a point here, you go toward asymptote, you go toward asymptote. The concavity below -2 is concave up, after 3 is concave up, between 3 and 2 is going to be what? Concave down. So this is how you graph it. And if I ask you show the interval of concavity, you have to show it to me like that. There are other questions that you can try. This is what I did here. Here is another one. -1/x + 2. You know, we have a vertical asymptote at 2. The restriction is the zeros in denominator. Horizontal asymptote is this line, y = 0. Then you find a point above and below -2. You will see this is positive. So you go toward asymptote without crossing that, toward asymptote without crossing that. Find a point here. You go through the asymptote, toward the asymptote, no cross that, and toward the asymptote and not crossing it. So, and you can draw it. There are other examples that you can graph, find the interval of the concavities, and do this question. So for each of this function, doing graphing that, number 1, f and h, number 3, d and h, you can do question number 4, and you can do question number 5.